Alright, this is a review of graphing quadratics in vertex form. We are always going to try to find the vertex first. This is an example starting with the parent graph, y equals x squared, which has a vertex at 0, 0. There's no numbers in the equation to show that it's been transformed, so we start at 0, 0. If we made a table just to plot points to see what the graph looked like, and we started at -2, -1, 0, 1, and 2, we could plug those into the equation. -2 squared is 4, -1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4. Plot those points. I could also do -3 squared is 9, or 3 squared is 9 to fill up the graph. And so that's going to be my quadratic shape. Kind of looks like an upside down arch. We call that a parabola. What I want to point out from the parent graph is the pattern we're going to use for the rest of our quadratic functions. The pattern that we used in class last semester was that the slope from the first point to the second point was going up 1 over 1 on both sides of the graph. The slope from the second point to the third point was going up 3 over 1. And the pattern for the last set from the third point to the fifth point was going up 5 over 1. And that pattern 1, 3, 5, 1 over 1, 3 over 1, 5 over 1 is what I can use to graph most of my quadratic functions. I can multiply that by something if there's a number in front of the parent graph, or I can use that 1, 3, 5. I can also make a table each time, but that's obnoxious and slow. It is effective, it's just a little bit slower. Let's look at another example. Y equals x squared minus 4. You should remember from last semester and from our DRQs that this minus 4 means that my vertex is going to be down 4 from the parent function. So instead of starting at 0, 0, I'm going to start at 0, -4, and I'll put that on the graph. I check in front of my quadratic expression. It's just x squared, 1x squared. That means that it's not reflected. It's going to open up, and I can use my 1 over 1, 3 over 1, 5 over 1 pattern to get the other points. So over 1, up 3 over 1, up 5 over 1. If I had room on my graph, I could go up 7 over 1. Do the same thing on the other direction, up 1 over 1 to the left, up 1 over 3, up 1, or up 5 over 1. I misspoke there. Up 1 over 1, up 3 over 1, up 5 over 1. Try to draw that as a curve, not as a straight line. That's my vertex. On the homework tonight, I'm also going to ask you to identify the x-intercepts. The x-intercepts are where it crosses the x-axis. Those are my x-intercepts. So in this case, my x-intercepts are going to be at -2, 0 and at 2, 0. Those are my x-intercepts. So the only difference in this graph was that I went down 4, so my vertex was at 0, -4. This number always moves the graph up or down. Next example. This one says negative parentheses x minus 3 squared plus 1. We're going to start with the vertex. The plus 1 at the end means that I'm going to go up 1. The minus 3 on the inside, we do the opposite, so we're going to go right 3. So my vertex is going to be right 3 and up 1 from 0, 0 at 3, 1. I do have a negative in front of the equation, which is going to reflect the graph or make it go upside down like this. But it is also a 1, so I'm going to do -1 over 1, -3 over 1, -5 over 1. So from my vertex, down 1 over 1 both sides, down 3 over 1 both sides, down 5, 1 over 1 both sides. And again, my x-intercepts are going to be where they cross the x-axis. So this time that's at 2 and 4. So 2 comma 0 and 4 comma 0. If this pattern 1, 3, and 5 is messing with you, you can try to remember it. You can come in and ask for help. You can also go back and make a table. The tricky part with making a table is you need to start with your vertex. So if I kind of give myself 5 spaces to work off of, I'm going to put my vertex in the middle of the table because I know that the vertex is the middle point. Then I'm going to choose numbers around the vertex to get the other numbers from my graph. So since my vertex was at 3, I'll go 4 and 5, and then I'll choose a couple numbers before that, 2 and 1. I can plug those into the equation for x and get the rest of my points. That's the other way to graph my function. I'll go through a couple more examples real quickly and then finish this video because we're getting close to a lot of time. My vertex here is going to be at -2, -6. Remember, we do the opposite for the inside number, -2, -6. And this one I have a number in front. We call that the scale factor or the multiplier. So I need to take my 1 over 1 pattern, 3 over 1 pattern, 5 over 1 pattern, and multiply that by 2. 2 over 1, 6 over 1, 10 over 1, which probably won't fit on my graph. So I'm going to take my vertex, go over 1 up 2. From there, I'm going to go up 6, over 1 up 6. And from there, I'm going to go up 10, but that's going to be off the graph somewhere. This time my x-intercepts are not integers, so I could estimate what they are. We're going to learn how to solve those later. So that's what my x-intercepts would be. This one is sometimes a tricky one. Just wanted to point out what that means for your vertex. This means I'm going to go 4 to the right, and there is no number out here, so I'm not going up or down. So my vertex would be at 4, 0 to start off the problem. -3 is my scale factor. And so if I use my 1 over 1, 3 over 1, 5 over 1 pattern times -3, I'll start by going down 3 over 1, down 9 over 1, and I'm not going to be able to do 15 over 1 on this graph. If I go down 3 over 1, 1, 2, 3, 1, even trying to get 9 below that is going to be off my graph because that's going to be a pretty steep curve. So that's your review of graphing quadratic functions in vertex form. Try out the worksheet, look at the answer key online, and good luck.